Okay, we have some understanding of what goes on in the disk. Let's look towards the center. Of course, if you thought it was hard to figure out the structure of the disk, understanding the structure of the bulge is more difficult yet. That is the direction where there is most obstruction by dust and so on. In fact, as I said, we only realized that the Milky Way has a bar, or this was only verified, there were suspicions earlier, in the past decade, so we're still learning very much about the structure of the Milky Way galaxy. In the bulge, we find, as I said, stars of varying ages with varying populations. An interesting reversal of what we're used to happens in the bulge. The oldest populations of stars in the galactic bulge turned out to have high metallicity, so they have high, relatively, concentrations of non-hydrogen and helium elements, whereas the newer stars are more metal poor. The interpretation that we put on this is that presumably early in the galaxy's history there was a burst of star formation in the bulge. This formed many hot large stars which exploded as supernovae, enriching the bulge region in metals, and therefore subsequent stars that formed shortly thereafter were metal rich. Subsequent to all of this, there must have been an infall of fresh, unenriched matter from regions of the galaxy where star formation had not yet started, so where there had not been supernovae to enrich the environment. This brought in relatively low metallicity hydrogen, and subsequent generations of stars formed in the bulge would have formed in a metal poor environment. And the bulge is one of the regions in which ongoing star formation seems to be going on as we speak right now. I think it's hard to see the bulge. Of course, the most interesting action in some sense is at the center, in the core. Seeing the core is harder still. Infrared observations allow us to peer through the dust to some extent and find that at the center of a galaxy is a dense cluster of stars, including a bunch of stars with, you'd call them type O and B, so hot blue stars, but with luminosities far exceeding what we expect for main sequence type O and B stars. Luminosities of 1 million solar luminosities per star. One interpretation of this is that these may be Wolf-Rayet stars, so older stars from a starburst episode about 10 million years ago, which are now very luminous. Remember, we're measuring their the luminosity of an OB star in the infrared. These may be having extreme infrared emissions because they are Wolf-Rayet stars. There are many puzzles about the goings-on at the center of the galaxy. For example, there is evidence for a very dense molecular cloud, but no ongoing star formation. The conditions are right for star formation, but star formation does not seem to be going on. At the center of it all, of course, sits our 3 or 4 million solar mass black hole in the center of the galaxy. Black holes in general, just a black hole in the middle of nowhere, is hard to detect. Indeed, black holes are detectable when they accrete matter. The black hole at the center of the galaxy is accreting matter at a modest rate. There is some X-ray activity. There are occasional flares, but there is not large bursts of activity, as we will see occur in some other galaxies. And to give you a sense for what infrared radiation does for us, we can watch this video courtesy of ESO, which zooms in on the center of the galaxy in visible light. You see we're looking right into the heart of the constellation, the tip of the teapot, of the spout of the teapot that is Sagittarius, but more importantly, right into the heart of a dust lane where we can see very little, and as we zoom in, the image goes pretty much grayed and dark, and the only way to see through this dust will be, this is the visible image, we are going to convert to infrared light and compare the visible image, which is this, not much, with, as the slider sweeps over, an infrared image which allows us to peer through and realize that these few dim stars that we see in the muck are in fact extraordinarily brilliant. Of course, the colors to the right are all fake. This is an infrared image, but this is the way in which infrared light allows us to peer through the dust and distinguish the goings-on at the center of the galaxy.